For question 2, it says that LORAN is a long-range hyperbolic navigation system. Suppose that two LORAN transmitters are located at the coordinates -60, 0 and 60, 0. So I'm going to sketch that to get an idea of what it is, but I've already been told that it's hyperbolic, so I know I'm going to be dealing with the equation of a hyperbola. Trying to stay where you can see me. So I'm just going to sketch a number line, and actually I'll make it a coordinate plane, and I'll start at 0 and go over to the right 60. So I'll count 20. Let's see, 1, 2, 3, 4, 5, 6. We'll make each of those be 10. So this would be 60, 0. That's one of the points that was given. And then -60, 0. 10, 20, 30, 40, 50, 60. -60, 0. I don't know what those points are yet. I'm going to keep reading and put as much information as they've given me onto this graph, onto this coordinate plane. Alright, the distance on the coordinate plane is measured in miles. You need to keep that in mind when I answer. A receiver is located somewhere in the first quadrant. So this is quadrant 1. And we have some kind of a transmitter that's shooting out radio waves or some kind of signal to measure a distance from the receiver to transmitters. The difference, not the distance, but the difference in the distances. So this is going to be hyperbolic again. The equation, let me see if I can stay in sight here. The equation for a hyperbola is going to be, in this instance, it's going to be opening up in the x direction, because I've already got these 2 points plotted here. They're either going to be the vertex or the foci. I'm not sure which yet. So it's going to be, start with the x, so it's going to be x squared over a squared minus, a hyperbola talks about difference. That's how we plot those points. Minus y squared over b squared equals 1. So we're going to be plugging in a squared and b squared into this equation. But we've got to find them first, because I still don't know what this distance is from 0 to 60. I know it's 60, what did it say, miles? But I don't know whether that's distance A or distance C. To the vertex would be A, to the foci would be C. Alright, so this transmitter gives us some more information. It's going to be shooting out signals, and we'll have a distance from here to here. So 10, 20, 30, 40, 50. It's going to be measuring from here to here, and from here to here, and I'll show you how I know that in just a minute. And then this distance, we'll call this x and we'll call this y. Y minus x is going to be a squared plus b squared is c squared. So what did I call that? A. Y minus x, y squared minus x squared equals 100. Let me think about that for a minute. Alright, the equation. Alright, so I know that this distance right here is 100. Half of that's going to be 50. So I can put another point here at 50, 0, and here at -50, 0. Now that I have these 2 points plotted, this is the center at 0, 0. So this distance here is 50. Again, I'm looking 50 miles in either direction. So this is going to be the vertex. If I kind of sketch this out, because the foci are not going to be part of the graph. They're going to be inside that hyperbola. Alright, so I have A. A is equal to 50. And I have C, because the distance from the center to the foci is C. And I'm going to use my formula to calculate B. And that formula is B squared. Let's see if I'm still in sight. B squared equals C squared minus A squared. We have C is 60, so C squared is 60 times 60, 3600. A squared is 2500. So 3600 minus 2500 gives us B. Gives us B squared. So B squared equals 1100. So I have B squared and I have A squared. I'm going to put those into the formula. So it's going to be X squared over 2500 minus Y squared over 1100 equals 1. I think setting up that sketch, which got kind of messy here, was the hard part in the beginning, to orient yourself to where everything is. And then once you have that, then you can just plug everything into the equation. Alright, I hope that helps.